Have you ever imagined what secrets the ocean depths might hold? What if I told you there's something called dark oxygen being created there? A mystery as profound as the abyss it originates from, dark oxygen has piqued the curiosity of scientists and researchers across the globe. The concept of dark oxygen seems straight out of a sci-fi novel, but let me assure you it's very real and very intriguing.
A groundbreaking discovery in the depths of our oceans may just reshape our understanding of oxygen production and its environmental implications. Scientists have uncovered something extraordinary in the dark abyss of the ocean, 5 kilometers below the surface.
Picture this: oxygen, a gas we associate with life and light, being produced in the heart of the ocean's darkness. This phenomenon is a testament to the wonders our planet holds, and how much there is yet to learn. Dark oxygen is not your everyday oxygen, it's a byproduct of a complex process involving tiny marine microbes and the energy from solar radiation. These microbes, dwelling in the profound depths of the ocean, engage in a fascinating dance with sunlight that reaches them, creating what we now know as dark oxygen. This unexpected discovery has raised more questions than answers. How does this process occur so deep in the ocean, where sunlight is a scarce commodity? How does it contribute to the overall oxygen levels on our planet? And perhaps most importantly, how can we utilize this mysterious dark oxygen? Mining companies, ever on the lookout for new resources, have turned their sights to the ocean floor. The dark, oxygen-rich areas are seen as potential gold mines for battery production. But this prospect of underwater mining has sparked a new debate. Are we on the brink of unlocking a Pandora's box of environmental issues? So we have a new form of oxygen being produced in the dark ocean depths, but how exactly does it happen? Let's dive deeper. The production of dark oxygen is a fascinating process that takes place thousands of feet below the ocean's surface. It's a world where sunlight never reaches, yet, surprisingly, it involves solar radiation. But how is this possible? Let's dive in. The story begins with marine microbes, tiny organisms that thrive in the deep ocean. These microbes have a unique ability to absorb solar radiation even at these incredible depths. Here they interact with lumps of metal that settle at the bottom of the sea, a byproduct of Earth's geological processes. It's a peculiar dance between biology and geology, happening in the dark abyss of our oceans. As these microbes absorb solar radiation, they trigger a chemical reaction with the seafloor metals. This reaction results in the production of what we now know as dark oxygen. It's a process that's as intriguing as it is complex, involving elements from both the living and the non-living world, all happening in a place where the sun doesn't shine. The creation of dark oxygen is not a one-off event, it's a continuous process, happening every moment, as long as there are marine microbes, solar radiation, and metal lumps. It's a testament to the wonders of nature, showing us how life, in its various forms, can adapt and thrive even in the harshest conditions. So, we now know how this mysterious dark oxygen is created. But what can it be used for? The answers might surprise you. You might be wondering, what's the use of oxygen from the ocean floor? Well, it turns out the potential applications are quite significant. Dark oxygen, this seemingly alien substance from the ocean's abyss, holds some remarkable possibilities. One of the most intriguing is its potential use in battery production. Yes, you heard that right. The batteries that power your smartphones, laptops, electric cars, and countless other gadgets could one day be powered by oxygen harvested from the ocean floor. So, how does this work? While the specifics are complex, it boils down to the unique properties of dark oxygen, which make it an excellent candidate for energy storage. It's capable of storing energy in a compact, efficient manner, making it an attractive option for battery manufacturers. These companies are now exploring the dark, oxygen-producing areas of the ocean, looking for ways to harness this incredible resource. But it's not just about batteries. The potential applications of dark oxygen extend far beyond that. With more research, we might discover new, unimagined uses for this resource. Could it be used in medical applications? Could it revolutionize our energy sector? Or perhaps it could even be used in space exploration. The possibilities are as vast as the ocean depths where dark oxygen is found, but while the promise of dark oxygen is exciting, it's also not without its challenges. Extracting this resource from the ocean floor is a complex and potentially risky process. It requires advanced technology and careful planning. Plus, it raises questions about potential environmental impact. After all, the ocean is a delicate ecosystem, and any disruption could have far-reaching consequences. With every new discovery, there's always a flip side, and with dark oxygen, it's no different. This hidden treasure of the deep ocean, this dark oxygen, doesn't come without its potential drawbacks. While the thought of a new energy source is indeed thrilling, it's critical to consider the possible environmental implications. Disrupting this balance, as with any natural process, could have far-reaching consequences. The extraction process might disturb the marine life, disrupt the habitat, and potentially lead to the extinction of some species. Moreover, the extraction of dark oxygen could possibly alter the chemistry of the ocean. This might not sound like much, but even a slight change in the composition of seawater can have a significant impact on marine life. Changes in the ocean's chemistry can affect the availability of nutrients, disrupt the food chain, and even influence the global climate. In addition, the machinery used for extraction could introduce pollutants into the ocean. Oil leaks and the release of harmful gases are a common occurrence in mining operations. If these pollutants seep into the ocean, they could contaminate the water, harm marine life, and even enter our food chain. So the question is, do the potential benefits of dark oxygen outweigh the possible environmental impacts? That's a question scientists are grappling with. And while research continues to understand and mitigate these concerns, one thing is clear: we must tread carefully in our pursuit of this new energy source. The ocean is not just a resource to be exploited. It is a complex, delicate ecosystem that sustains life on Earth. As we stand on the brink of this new frontier, it is our responsibility to ensure that our actions today do not compromise the health of our oceans tomorrow. But what cost might we pay for digging too greedily and too deep? This is a question we must grapple with as we move forward. As we stand on the brink of this new frontier, the future of dark oxygen is both exciting and uncertain. It holds promise for technological breakthroughs, but also potential pitfalls. Our choices now will shape the course of this journey. The task is not a small one. It's a journey that requires us to tread carefully, balancing our thirst for knowledge and progress with our responsibility to protect and preserve. But it's a challenge we're ready to meet head-on. As we continue to unravel the mysteries of dark oxygen, one thing is clear: our journey into the depths of the ocean is just beginning. What's your critique? Let me know in the comments below.